Welcome to this final lesson in the series of Surds. This will look at the harder stages of rationalizing the denominator, taking it further than we did in the previous lesson. Hopefully you managed to have a go at some of those follow-up questions and mark them from the solutions given, and also have a go at these starter questions. We will begin by looking at these questions here. So if you found them a little bit difficult, you're about to see my solutions now. Expand and simplify 2 plus root 3 and 2 minus root 3. So again, we looked at expanding with the FOIL method. So the first thing we're going to do is 2 times 2, which is 4. Then we're going to multiply, and again, I'll always say it, that is not root 3, it is minus root 3. And if we multiply that together, we'll get minus, because a positive and a negative makes a minus, and then we will have 2 root 3. Expanding out root 3 with 2, we would get plus 2 root 3. And finally, we've got a positive times by a negative, which is going to give us a negative. And then recall that root a times root a, the same surd times together gives you just the surd inside, so it cancels the square root. So root 3 times root 3 will be 3. Then we have to simplify, so we've done the expanding stage, now we need to simplify. What goes together? We've got two whole integers, 4 and minus 3. And then we've got minus 2 root 3 plus 2 root 3. So by combining this together, 4 minus 3 is 1. And interestingly, minus 2 root 3 plus 2 root 3, that will cancel to 0. So the final answer for this is simply 1. What you see here is the surds cancel. Given basic number line, minus 2, if I add 2, gets me to 0. Okay, so hopefully you managed to get that one. And that is both steps done. Moving over to the top right question, you've been asked to simplify 2 root 3 plus 5 root 12. We looked at, these are two different roots, and we discussed how if the root is not the same, you cannot add them together. However, we know that we can manipulate and simplify surds to see if we can get them the same, and we spent a section of last lesson looking at how can we do that. So you should have noticed straight away, root 3 can't go any further. That is as simple as it will go. 3 is a prime number and no square number goes into 3. 12, however, if we list out our square numbers, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. We don't need to go any further because we're only trying to get a square number into 12. The method, we're going to leave this one the same, and we're going to add 5 lots of 2 blank surds. That was the exam skill that I taught you. If you're going to simplify a surd, just write 2 blank surds times together, ready to be filled in where 1 is a square number. Now ask yourself, which one of these square numbers, clearly not 16, go into 12? Well, 4. 4 goes into 12. Then you work backwards, you think, how many times does 4 go into 12? What do I times it by? 3. We can now tidy up. We've got 2 root 3 plus, well, what is root 4? Why do we always want to get it as a square number? Because root 4 simply goes to 2. So we've got plus 5 times 2 times root 3. And again, we can simplify some more. We've got 2 plus root 3 plus, well, what would 5 and 2 go to? Because we can times those, that would be 10 root 3. Surprise, surprise, we can now add them together because we have the same root of 3. So 2 root 3 plus 10 root 3 would be 12 root 3. And that would be that question done. So hopefully you managed to get that. If we now go across to the bottom right question, it's asked us to simplify this. Okay, and I discussed with you last lesson that it doesn't always just say rationalize the denominator. you have to be very clear that simplifying a surd that has a fraction with a surd on the bottom is telling you to rationalize. So you should see the surd at the bottom of a fraction and see the word simplify and think to yourself, I need to rationalize this. And we discussed, what does rationalize a surd mean, or the denominator? It means get rid of the surd on the bottom. So we looked at a technique how to do that, which was, if we need to get rid of this root 2, the only way we can do that is by timesing it by the same surd. So we're going to times it by root 2, because root 2 times root 2 cancels the surd and leaves you with 2. We also looked at, you have to be sure whatever you do to the bottom, you do to the top. So we must times the top by root 2 as well. Then it is a case of multiplying across, given our basic fraction understanding. That would be 5 root 2 over root 2 times root 2 would just give me 2. And that would be your final answer for that. So there, we've still got the surd, but it's gone from the bottom to the top. And that's the goal of rationalizing the denominator. It's just to get rid of the surd that was on the bottom. So very similarly, question number 4, the final one. Very same or similar technique, sorry. Just a little bit more involved because the numerator has got more than one term. We need to get rid of this root 3. So we need to rationalize. We're going to do that by the same technique, times the bottom by root 3. So we must times the top by root 3. Exam skill, there is more than one thing here, one term, so you're going to put it in a bracket and make sure that it all gets times by root 3. So that is going to give you 1 times root 3 is simply root 3. You could write 1 root 3, but there is no point. 3 times root 3. Root 3 times root 3 is plus 3 over, and now we're going to times across. Root 3 times root 3 is simply 3. So your final answer would be root 3 plus 3 all over 3. An alternative version, and we looked at this last lesson, I would leave it like this. But if the question wanted it in a different form, we could split this as over 3 and we could split this as over 3. So we would end up with root 3 over 3 plus, if we split this, what is 3 divided by 3? 1. So that is exactly the same as that, just in a different form. I would just leave it as this though. Unless really specified, there is no point wasting time doing that. This is just as good of an answer. Okay, moving on. Rationalizing the denominator, part 2. This is where things get a little bit more tricky. We're going to look at a case study here, and we're going to be asked to rationalize 6 over 4 plus root 3. Now, we have seen already in the starter, note back that you need to get rid of the surd on the denominator. Why this is different to what we've seen before is, all we've ever seen before is 1 surd on the bottom. Now we've got more than one term. So I don't want you to write this, and I've written it very clearly, do not write this. So I just want you to watch, follow along in your head. I'm going to try and use the same technique as we've seen previously, and we're going to just explore what we get. So what we've seen so far is we times the bottom by the same surd to eliminate it. So let's give that a go. I'm going to times top and bottom, and again, you don't write this, just watch. I'm going to times top and bottom by root 3, because that is what I told you last lesson. So whatever the surd is on the bottom, times it by the same surd, and it will cancel, because root 3 times root 3 is 3. And we need to do the same to the top, so we'll times the top by root 3. So let's do that. If we times the top, we're going to get 6 root 3. And if we times the bottom, remember there's more than one term, so it must go in a bracket, and I need to times both things. So 4 times root 3 is 4 root 3. And then root 3 times root 3 is 3. So I managed to eliminate this surd by getting 3. But as you can see, I haven't done what I told you rationalizing the denominator meant. I told you it meant get rid of the surd that was on the denominator. Now you can clearly see here, we've just ended up with another surd. We've just moved the surd from here to here. So this is wrong. Our technique by timesing by the same surd on the bottom does not work. So we need to find a way, how can we use a similar technique using the same method? Clearly, root 3 is going to be required to eliminate this surd. Okay? But the problem is, because we've got a whole integer here, by timesing that by root 3, we end up with 4 root 3, which just creates another problem. So, how are we going to do this? We need to refer back to our starter question. So if we go back to the beginning, we've actually seen it already today. If we look here, we had 2 terms with 2 surds, and somehow we ended up with no surds. So what's happened there? Well, the key to this question was we ended up here with minus 2 root 3 and plus 2 root 3, which cancelled. And if you take a look at this question, you had the same thing, 2 and root 3, with just 1 positive and 1 negative. And what that does, when you expand it, it cancels the surd. So we're going to take that understanding and we're going to develop our already basic understanding of rationalizing denominator and just add in that extra step. So if you're a little bit unsure, you're about to see what I'm talking about now. Clearly, we've just shown we can't just times by root 3 because you don't get rid of the surd. So what we need to do is we need to go a step further and times by the same thing and flip the sign. And that will hopefully eliminate all of the surds. So the extra surd that would have been created will get cancelled out because you've got 1 positive and 1 negative. This is much easier to see in action. So what we're going to do, and you can start writing this now. You're free to write this. We're going to take the surd, which is 6 over 4 plus root 3. And we're going to times it by exactly the same as what's on the bottom, but we're going to change the sign. So we're going to times it by 4 minus root 3. Remember, whatever you do to the bottom, you have to do to the top. So we're going to times the top by minus root 3 as well. So hopefully at this point, you can understand why we needed to do all of the parts of surds we have already. The expanding surd brackets, the rationalizing, it all leads to this. So if we expand this now, and by doing so, we're going to put brackets around everything that has more than 1 term. So we'll deal with the top first. If we deal with the top, we're going to do 6 times 4 and 6 times minus root 3. So what's that going to give us? That is going to give us 6 times 4 is 24. And 6 times minus, remember that is minus, it's not just root 3, it's minus root 3, is minus 6 root 3. The bottom, you've seen already today in the starter. What I'm just going to do, and I like to do this, is I'm just going to take the bottom and I'm just going to do it off to the side. So I'm going to take this denominator, I'm just going to do it off over here, so I've got a bit more space. So I'm just going to copy it out, just so I can clearly put my lines in. So 4 times 4, 16. 4 times minus root 3 is minus 4 root 3. 4 times root 3 is plus 4 root 3, so hopefully you can sort of see something that's good for us there. And then we're going to do plus and a minus is a minus, and then root 3 times root 3 is 3. The surd cancels. You might be thinking, well, we've still got surds, but if you look closely, if we simplify this, we've got 16 and minus 3, and we have 4 root 3, minus 4 root 3, and plus 4 root 3. Well, what is that? What happens there? That cancels. That goes to 0. So all we have is 16 minus 3, which is 13. So our bottom denominator, when expanded, simply gives us 13. So our final answer is 24 minus 6 root 3 over 13. And as you can see, exactly as discussed, happened. By flipping the sign and timesing by the same thing, we eliminated the surd when simplifying, because we had one plus version, one minus version. And that will always work. So the trick, when you have more than one term, and I think we should write this. Definitely write this, I reckon. So we're going to say, if your denominator has more than one term, so in our case we had when I say term I just mean a 4 and a root 3. It's a more than one term, including a square root, including a surd, because the goal is to get rid of the surd. If it has more than one term, including a surd, multiply by the exact same terms and change the sign. Okay, so that is the goal. You've got the same problem where you have two terms on the bottom, you times by the same exact two terms, you just flip the sign. So if it's a plus, you change it to a minus, and if it's a minus, you change it to a plus. Okay? So, very, very similar, just an extra step involved. If we look at the next question, we can see some examples. So what do these examples say? Well, we've got 6 over root 3 plus 5. So I can see that I have a denominator with a surd with more than one term. So I'm going to want to get rid of that surd. That's the goal. Yeah. Simplify this, rationalize the denominator. We're going to use that technique we've just seen. We're going to times the bottom by the same thing, but I'm going to change the sign. It is a plus here, so I'm going to change it to a minus. And again, fraction rules apply. I have to do the same to the top. So I'm going to times the top by root 3 minus 5. That is going to now involve some work expanding this out. So if I expand this out, the top, anything that is more than one term needs to go in a bracket. If I expand out the top, I will simply get 6 times root 3 is 6 root 3. 6 times minus 5 minus 30 over. Now I always recommend you take the bottom two denominators and write them out again, so you got some space to work on them. So we're going to do root 3 times root 3 is 3. Root 3 times minus 5 is minus 5 root 3. And you should be getting good at these now. 5 times root 3, the expanding part that is plus 5 root 3. And then minus 5 times plus 5 is minus 25. Okay. What happens here? These two surds will cancel, and the square number and the whole numbers can be simplified. So we've got 3 minus 25 is minus 22. And then you've got minus 5 root 3 plus 5 root 3, which cancels to 0. So we just end up with minus 22. So the bottom of this will be minus 22. And that would be our final answer. Okay. And these examples just follow that same system. It's just got that additional step where we have to times top and bottom by the same two terms with a change in sign. And that helps us eliminate the surds. So here we're going to times this by 4 minus root 3, and we're going to change the sign to a plus root 3. And we're going to do the same to the top. And then we're going to put brackets around things that have more than one term to help us make sure we don't miss things when expanding. The top can always be expanded a lot easier than the bottom, unless of course there are two terms here, and then it's the same, which generally exam questions do like to throw harder things of that nature at you. So timesing this, we've got 5 times 4 is 20. 5 times root 3 is plus 5 root 3. So that is the top done. We're going to take the bottom and we're going to expand it off down here. So we're going to get 4 minus root 3 times by 4 plus root 3. And by doing this, we're going to get 4 times 4, 16. 4 times root 3 is 4 root 3. Minus root 3 times 4 is minus 4 root 3. And again, that is good for us because you've got the same term, 1 plus 1 minus. And then minus root 3 times plus root 3 is going to be minus 3. So again, we can tidy up now. We've got 16 and minus 3. And then luckily for us, these surds, these 4 root 3s are going to cancel. So we're just going to end up with 16 minus 3, which is 13. So again, our final answer, 13 on the bottom, we will get 20 plus 5 root 3 over 13. Now, how have we done what we needed to do? Yes, we have eliminated the surd that was on the bottom. We now have a whole integer on the bottom, a whole number. So all good. And moving on to the last example. We can see very, very similar question. Just the top looks a little bit more involved. We're going to times top and bottom by the same denominator with a change of sign. So that would be 5 plus root 3. Because as discussed, that is what is going to eliminate our surd from the bottom. It's not going to create any more surds. Maybe on the top, but not the bottom. We're going to put a bracket around anything that has more than one term in it. And then we're simply going to expand. Now I'll talk you through this top expansion. We've got 4 root 5 times by root 5, sorry. Well, remember, that just means 4 root 5 times 5, and we've looked at this in previous lessons. That is simply, it's all commutative, it can be done in any order. That is 4 times 5 and then root 5, so that would be 20 root 5. Okay, because you can just put these in any order, so you can bring the two whole numbers together and times. So that will give us 20 root 5 for the first bit. The second bit says 4 root 5 times by root 3. So remember, 4 root 5 times by root 3. There is a law that says we can combine these two surds by writing 4 times 5 root 5 times root 3, all inside the same square root, which will give you 4 root 15. So 4 root 15 is what will go there. So that'll be plus 4 root 15. We could try and simplify root 15, but no square number goes into 15. So there's no point. And then again, a good technique is to take the bottom double brackets off to the side, do your expansion so you don't make mistakes and you're clear with your workings. So that is 5 times 5 is 25. Got 5 times root 3 is plus 5 root 3. Minus root 3 times 5 is minus 5 root 3. And minus root 3 times plus root 3 would give you negative. A mixture makes a minus, negative 3, because the surds will cancel. Again, we need to simplify. The 25 and the minus 3 can go together. And the 5 root 3 and the minus 5 root 3, luckily for us, cancel to 0 because that's what we want. So we've just simply got 25 minus 3, which is 22. So our denominator will be 22. And that would be our final answer. So as you can see, that one just had a few extra parts to think about on the top expansion. And you can see that you need really good fundamentals with the basic Surds 1 lesson I taught you to not make that top bit difficult. That should just be, I can do that. It's all very straightforward because I've practiced Surds 1 and Surds 2. Okay. So those examples will be very useful for you when looking at further questions, when revising. The next question, example 4. Now this requires not only our Surds understanding, but also some basic fraction laws. So note back, we're going to need some basic fraction laws. Okay, and we'll make some notes alongside there in a moment. This says show that 1 over root 3 plus root 3 can be written as root 3 over 4. So somehow we need to use every little bit of rationalizing the denominator that we've learned to turn this horrible looking expression into something as simple as root 3 over 4. So the first problem that we've got 2 surds on the bottom. That's a problem. The second problem is one of these surds on the denominator is also a fraction. So the first note that we're just going to add, so when you refer back to these it will make sense, is we don't want a fraction or a surd on the denominator. So our first problem we've got here is the fraction. That is the first problem. We definitely don't want a fraction on the bottom of this denominator. And then further to that, we don't want a surd either. We know how to get rid of a surd, but at the very moment, we don't actually know how do we get rid of a fraction. Okay, because our usual technique won't necessarily work. So the first thing we're going to do is we're just going to take this expression. Okay, we're going to take the denominator and we're going to focus on seeing what we can do with that before we try rationalizing. Before we try our rationalizing techniques, we're going to take the denominator because the first thing we identified here is we don't like the fraction. So we're going to focus on, can we get rid of the fraction? And this is going to refer back to some very basic fraction rules and techniques. So let's focus in on this. We need to somehow eliminate this or get it as one fraction. We don't like this fraction, and this technically is a whole number. So the first thing that you should be very clear on, and a really good exam skill and mathematical technique, is any whole integer, any term can be turned into a fraction by simply writing over 1. And we'll add that note. You can turn terms that aren't fractions, so terms, any term, any whole term, in this case a whole surd, any term into a fraction by putting it over 1. So for example, the number 4, if I were to turn 4 into a fraction, it's technically 4 over 1. Because how many 4s go into 1? Oh, how many 1s go into 4? 4, so that would just be 4. What would 100 as a fraction be, technically? 100 over 1. What would 1,000,000 be as a fraction? 1,000,000 over 1. So we really need both of these as fractions to try and get them simplified. So by putting this over 1, we are now looking at a nicer problem for us because it's now adding two fractions together. We know how to add two fractions together. What do we need? To add two fractions together, we need a common denominator. And as I go through, so the next topic that I'll be doing for the higher year 9 and higher year 10 will be algebraic fractions. As we go through these topics, you'll realise that I'm going to just be assuming you can do basic fraction stuff. Here I'm going in depth with it, but you're going to have really solid understanding of basic fractions. So to add 1 over root 3 and root 3 over 1, we got to make sure there's a common denominator. Well, this denominator is root 3, and this denominator is 1. What could we turn them into to make them the same? Well, whenever you've got 1 as a denominator, you can just change that into the other one. So I could make this 1 root 3. How would I make it root 3? I would multiply top and bottom by root 3. Okay, so we're going to leave the original fraction as 1 over root 3 plus, now to make a common denominator, we're going to times this one by root 3, and we're going to times, remember fraction rules, if you do something to the bottom or the denominator, you've got to do the same to the top. We'll times the top by root 3 as well. Okay, so if I highlight that in a colour that sort of illustrates what I'm doing. To make a common denominator, I've realised 1 could be turned into root 3 by timesing it by root 3, and I must do the same to the top. So if we look at what happens there, and again, this is going to now feed into your Surds understanding. What is root 3 times root 3? Well, that is 3. What is 1 times root 3? Well, that is just root 3. Now I have a common denominator, which means I can add these two fractions together. Remember, when you add fractions, you leave the denominator the same, so it's going to be root 3. And we're going to add the top, so we've got 1 add 3, which is 4. Okay, so we have now dealt with this problem where we had two fractions, and now we've got it down to one fraction. So we don't want the fraction on the bottom or the surd. But what does this tell us? It tells us this is 1 divided by what we've just worked out, 4 root 3. So I could say that what we have now got, and I'm going to use this symbol, so this means, therefore, very useful in maths when you're when you're sort of going from one, when you've said a couple statements, so we've said some statements here, now I want to say therefore I've got, rather than equal sign, therefore fits better, I've got 1 over 4 over root 3. So I've sort of got rid of the horrible looking fraction and surd and turned it into just one fraction. Well, what do we know about fractions? Now you need to know about dividing fractions. This technically says we could write this as 1 divided by 4 over root 3. Okay, that's what that says. That and that are exactly the same thing. We're going to use that same technique. We've got a fraction and a whole number. We would rather have them both fractions, so I can write 1 as 1 over 1 to turn it into a fraction. What's the rule when we divide? When we divide KCF, keep, flip, keep, change, flip, keep, change, flip. So we're going to keep this 1 over 1. We're going to change the divide to a times, and then we're going to flip the last fraction. So we're going to get root 3 over 4. Now we know, don't we, when you times fractions, you do that times that and that times that. So that would be root 3, because 1 times root 3 is root 3, over 4. So, what we have done there is used a variety of skills to take us to the final answer. Look, can it be written as root 3 over 4? Well, that is what we just got, so that's correct. First thing you should have done was take the denominator and do some basic fraction rules on it. And they look really confusing because you're dealing with surds as well. But a really key thing to note is changing that surd into a fraction by writing over 1. It's really useful. Getting a common denominator, adding them together, then putting it back in for what you had, realizing this just means this, knowing your fraction divide rules, and then what you find is it naturally rationalizes itself because it was a division of a fraction and a fraction, or a whole number and a fraction. The flipping of the divide, the basic fraction rule of divide, made us flip, or do the reciprocal is the technical word for it, what we were dividing by, which moved the surd onto the top. So it naturally rationalized itself. So that is very complex. That is one of the harder, probably the hardest surds question that you're likely to see in an exam paper. There is an opportunity for you to practice. You've got some questions here where you can use my examples. My examples are very closely mapped to the questions that I've put for you here. I will link the solutions in the description box, along with, I've also linked some harder surd questions to continue your practice. So when you've done the ones on this worksheet, you can mark them. If you've got any questions, just message me on this video or on Facebook, and then we can look at the further harder surd questions, which are also in the description, which I will link solutions for. Hope you learned something there. And if you're unsure about, if you've tuned in late and you've not seen any of the previous surds lessons, this will be very difficult for you. I'd highly recommend to go back and watch Surds 1 and Surds 2. If you still struggled with some of this, it might be worth re-watching Surds 1 and Surds 2, just to really secure that knowledge, because the stuff we've covered today, unless you have got really strong understanding of 1 and 2, this will be very difficult. But thanks for tuning in, and I'll see you in the next one.